Alright, just like when we're adding and subtracting fractions involving just numbers, when our fractions involve variables, the same principles hold. We just want to have a common denominator. And if we have a common denominator, then we can add or subtract the numerators. So for a here, we already have a common denominator of 2xy. So we can actually just combine all those numerators into one line. And then we'll put them all over their common denominator of 2xy. So this is going to be 3 minus 7, which is negative 4. Negative 4 minus 9 will be negative 13. Negative 13 over 2xy will be our final answer. For b, we also have a common denominator already. So we'll just want to do negative 3 plus 8 minus 3 over 4x squared. That's going to give us 2 over 4x squared. We can simplify that. We'll just divide both the top and bottom by 2. So we'll get 1 over 2x squared. For letter C here, we'll have x minus 2 over the common denominator of x squared minus 3x plus 2. But we do want to check and see if we can simplify farther. It is possible that maybe we could factor that denominator and reveal a factor which might match with the numerator. Let's see. X squared minus 3x plus 2 can break into x minus 2x minus 1. And so yeah, it did turn out that we could actually go farther and cancel the x minus 2 factor. We'll have 1 over x minus 1. Let's see, for D we'll have 3x minus 5 over 3x squared plus x minus 10. And let's see if we can break that denominator up. Let's try 3x and x here. I think we need 3x minus 5 and x plus 2. And yeah, 3x minus 5 can cancel. So our final answer here will be 1 over x plus 2. Now with E, they don't have a common denominator. So we're going to have to find the common denominator ourselves. Alright, so we want to think of what kind of multiples we could form out of 2, 5, and 10, and what would be the least common multiple between them. I think that for the numbers, 10 would be a great least common multiple. And then when it comes to the variables, we just want to keep the highest power of every variable that appears in our least common multiple. So the LCM, least common multiple, for these three denominators will then be 10 x squared y. So the reason for this is 2 times 5 will make 10, 5 times 2 will make 10, and then 10 times 1 makes 10. So 10 is the least common multiple of those three numbers. When it comes to the variables, let's see, x squared is the highest power of x that we have, so we definitely want to keep that, because the others can be multiplied by an x to make x squared. And then these two terms have a y in them, so we want to keep that. And we can multiply the 5x by y in order to make it into the least common multiple. So now let's just figure out what we have to multiply our tops and bottoms by to get the LCM. So one technique for doing that is to put like parentheses next to each term. And so if we multiply the top and bottom by the right choice here, we can turn the denominator into a 10x squared y. So the right choice for this one would be to multiply by a 5. So we'll just multiply by 5 over 5 here, because that'll make our denominator into 5 times 2, which is 10x squared y. For our middle term here, we've only got a 5x, but we need 10x squared y. So we better multiply by 2xy, actually, on both the top and bottom. Since we're multiplying by something over itself, it's just 1, so we're not really changing the value of that term, but we are going to be changing the denominator into 10x squared y, which is what we need. Here we've got 9 over 10xy, so let's multiply by just x over x. That'll give us the 10x squared y that we need. Okay, so with fraction multiplication, we just want to multiply straight across. So it'll be 5 times 3 makes 15. Down here we'll have what we needed, which is 10x squared y. Let's see, here we'll get 16xy on top, and we'll have 10x squared y on bottom, which is what we wanted. And then we'll have a 9x on top here over 10x squared y. So we can now combine the numerators because they have a common denominator now. It looks like they're not going to be like terms, so they're going to have to be kept separate. So we can just do 15 minus 16xy minus 9x. And we'll just put that all over 10x squared y. And that's as far as we can go with the simplification of it. For letter F here, we've got 5ab for this denominator, 10a squared b for the middle denominator, and 15ab squared for the third denominator. So let's use the factor tree method this time of finding the least common multiple. In the factor tree method, what we do is we find a factor tree for each of the denominators that we're trying to find a least common multiple for. So we could break them up into their number parts and their variable parts separately. Try to break the numbers all the way down. And then the technique is to find the tree that has the most of each prime. And then you keep that as part of your LCM. So 2 is one of the primes that appears. It appears one time in the middle tree and it doesn't appear in the left tree or the right tree. But we still keep it because it appeared once. So when we're making our LCM, we want to keep 1, 2. All right, the same goes for the 3. You look at the 3s and you look at the trees and see who's got the most 3s. Well, this tree on the right has a 3, the others don't. So since the one on the right has 1, we keep 1. And then when it comes to the 5s, the tree on the left has a 5, the tree in the middle has a 5, the tree on the right has a 5. But you don't keep all the 5s. You just keep the most number of times that it appears in any tree. So you can actually only keep 1 5. All right, that's how the tree can be used to find an LCM. So for just the numerical part of it, the LCM will be 30, and now we just have to focus on the variables. So for the variables, you look at which tree has the most A's and which tree has the most B's, and you keep however many repetitions you have in a single tree. So A appears once here, twice in the middle, and once on the right, so we got to keep 2 A's because you keep the most and you ignore the others. Here we've got 1 B on the left, 1 B in the middle, and 2 B's on the right, so we're going to keep B squared. Keep 2 B's. And that's how we find our LCM. Now our job is to build these fractions to higher terms. All right, so one technique is to multiply each fraction by something over itself of our choice. And we just have to make the right choice to create the denominator that we want. All right, so here we have to figure out 5ab times what will make 30a squared b squared. So if we were to put in a 6 here, let's say 6 times a times b, that would be the right choice. Multiply those things and you get 30a squared b squared. Over here we need a 3 and a b, because 10 times 3 makes 30. A squared just stays itself, and then b times b makes b squared, so we've created the denominator we need. 15ab squared needs to get multiplied by 2a. All right, let's multiply across. We'll get 12ab over 30a squared b squared. We'll get 9b over 30a squared b squared. And here we'll have 8a over 30a squared b squared. Now we'll consolidate them all into one fraction. And just looking at it, I don't think there'll be anything else that we can do to simplify it farther. So it's done.